Let us talk about the concept of guiding rays for spherical lenses. So in order to create an image, you need to collect a lot of light from different points, and what lenses or mirrors do is exactly the same thing. However, all those rays must come in the same phase from a particular point on object so that the image can be formed, and lenses exactly do that. So let us consider this particular lens over here, which is spherical lens, and there is an object placed at this point. Now there are three rays, just representing three different rays, going ray number 1, 2, and 3, and they are all meeting at the image I. So we are assuming that for this object the image is formed at this point. The question is, which of these rays will travel fastest and come in the same amount of time? The answer here is not ray number 1 will go fast or ray number 3 will go fast, but all three of them reach in the same time. Why do they reach in the same time? Ray number 1 travels greater geometrical distance, ray number 3 travels lesser geometrical distance. However, ray number 3 also has to travel larger distance in the lens, in the material of the lens, where speed of light is less. Say refractive index is defined as speed of light in vacuum upon speed of light in the medium. If refractive index is 1.5 typically for glasses, then speed of light in vacuum being 3 lakh kilometer per second, in the glass it will be 2 lakh kilometer per second. Ray number 1 will travel smallest distance through the glass, and therefore it will travel every time almost with very highest speed, the speed in air or speed in vacuum, effectively both are same. And hence it turns out that if the image is formed at distance at point I, all three rays travel in the same amount of time, and that is when there is a constructive superposition of all the rays and the image is formed. Now using this concept, we are going to talk about how one can decide where the image is going to form. Now for our further discussion, we will always show convex lens using an arrow like this. So this is a convex lens. Axis passing through the center of the lens perpendicular to the central plane is called principal axis, and for a lens there is a focus here. Okay, in fact there are two foci. Okay, this is the second focus, it's called. The first focus is on left hand side, but for image formation, whenever we are bothered about the real image formation, okay, the second focus becomes very important, so we will talk about that. Now a ray is going along the principal axis will travel straight. Okay, it will not bend, it will not get deviated, because the amount of deviation depends on how much distance the ray is incident from the center of the lens. So if there is no distance, if it is passing through the center, the ray goes straight. Now we are considering another parallel ray parallel to the principal axis, but incident at some distance from the center. After passing through the lens, it is passing through focus. You can similarly draw all sorts of different rays, the rays which are all parallel to principal axis, after passing through the lens will deviate so that they will pass through the focus of the lens. Now this is helpful for one of the guiding rays. The next concept, this particular distance of the focus from the lens is called focal length. Okay, and it is represented by say f. Also the plane passing through the focus perpendicular to principal axis is called focal plane. Okay, and all parallel rays incident on the lens ultimately meet in the focal plane of the lens. Now that is an important concept. Of course, in all this discussion we are assuming that the rays are making small angle with respect to principal axis. Okay, when we say small angle, what it means is we can approximate that tan theta is approximately theta when theta is measured in radians. Now when this approximation is valid with whatever number of significant digits we are interested in. Okay, in that case we can use this small angle approximation, and all our discussion is going to be restricted to that. Now here we have got a question that suppose an object is placed at this point, where will the image form? And we can draw the guiding rays. One ray is going to be from the bottom of this, it is along the principal axis, it is going straight without getting deviated. Now I want to draw a ray from the tip of this particular object which is not on the principal axis. So I'll draw a ray parallel to principal axis, and we know that after passing through the lens it will deviate in such a way that it will pass through the focus. We can also draw another guiding ray which will pass through from this tip of the object not on the principal axis but passing through the center of the lens. So when you do that, and you know that because the ray is passing through the center of the lens, it doesn't get deviated, it will go straight. Now these two rays are meeting at this particular point, and therefore we can say that the image of this point will be formed at this point. Okay, and we can then draw that image will be something like this, because image of an object placed on the principal axis will be forming on the principal axis, and image of this tip is going to form at this particular point. So we can say that the image of this particular object is inverted image. Okay, it is a real image and it is inverted image. Why real image? Because these rays are actually meeting over here. Now this is with the help of two guiding rays we can decide where the image is forming. Suppose the question comes that you block this particular lens, half lens, and this particular block obstacle is an opaque, which means it is not going to allow the light to pass. Now the question is where the image will form. Will the image be formed at the same place, or image will not form? So here we have to keep in mind that those guiding rays were only helping us to find where the rays will go. Every part of the lens is acting as a lens, and therefore this part of the lens is still exposed to this particular object. So the rays coming from this tip can still be incident on the this part of the lens and will get deviated and ultimately meet where the image is going to form. So to decide where the image is going to form, you may still use the same old idea of guiding ray. A ray passing parallel to the principal axis, after passing through the lens will go through focus. Ray passing through the center of the lens will go undeviated. Wherever these two rays are going to meet, the image will form. Of course, here in this case we can also show a third ray which is passing through the first focus, and after passing through the lens it will go parallel to the principal axis. So we may show something like this, and we see that they are going to meet exactly at the same point, and that's how we can say that the image is going to form over here. So even if obstacle is over there, what we can always say is the guiding rays are always going to help us to decide where the image is going to form. Whether the actual ray coming from the object will go along the guiding ray or not is immaterial. These guiding rays are only helping us to decide where the image will be forming. The rays which are incident on the some part of the lens is ultimately going to form an image at this point only. So every part of the lens acts as a lens is an important point here. Now suppose the object is not placed on the principal axis. If it is placed away from the principal axis, where the image will form. So here again what we can do is we can treat the two extremes of this particular object as two different points, and we can decide where the image will form. So we take a ray from the bottom of the object, a ray parallel to the principal axis, after passing through the lens will go through focus. Again another ray from the bottom of the object passing through the center of the lens will meet this first ray at this particular point. So we know that the bottom of this object will form an image at this particular point. What about top of the object? The top of the object, again we can draw a guiding ray passing parallel to the principal axis. After passing through the lens it will pass through the focus, and another ray, another guiding ray from center of the lens okay, will meet at this point, and we can say that the image will form ultimately at this particular location. The tip of that object, the topper tip of the object will form image here, the bottom of the object will form image over here, and we can show image like this. What will happen in this case? Now we can see here that this object is placed here and the lens is here, and the rays which are going parallel to the principal axis will not pass through the lens. Now will the image form? So assuming still that though here in the figure it is exaggerated, we can still assume that that the angle of the incidence is going to maybe making small angle with the principal axis, so small angle approximation is still going to work. Okay, what we can do is we can extend the lens at the top, and then we can say that now let us draw the guiding rays. So guiding ray from the bottom, okay, will form image at this point. Guiding rays will be from the top of that object will form image at this point over here, and then we can say that ultimately the image will form somewhere over here. Now here what we have done is, again we are using the same principle, that because the rays coming from the object are going to fall on the lens somewhere, they may not exactly follow the guiding ray rules. They are going to ultimately meet at these points. But how do we decide these points? For to deciding these points, we can use guiding ray principle. So how much will the ray deviate? Now suppose this particular ray is coming over here, okay, how much will it deviate? How do we decide that where will it go? Okay, now it is, of course, there is a formula which says that the amount of deviation is given by the h, where h is the distance from center of the lens to the point where the ray is incident, divided by focal length of the object. But it is possible to use guiding rays to decide how much the ray will deviate. What I have to do is just extend the lens and draw a ray parallel to principal axis. After passing through the lens plane, it has to pass through the focus, and another ray passing through the center of the lens will go undeviated, and then you know that this particular object is going to form an image over here. So any ray coming from this object will ultimately has to pass through this point, and the image will form like that. So this ray will get deviated by small angle, and it will pass like this. You can of course then say that any rays, all sorts of rays which are going to be incident at various different angles, ultimately will have to pass through the same point over here, and they will go like this. So guiding rays help us to decide, after passing through the lens, where the image will be formed.